Hello everyone, in this video I will present a quick introduction to deep learning and its application. What's machine learning? Let's first discuss some of the popular quotes on machine learning. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Hilbert Simon describes the learning process as any process by which a system improves performance from experience. And finally, Tom Mitchell put a definition of machine learning as the study of algorithms that improve performance for some given tasks with experience E. Based on the above, a well-defined learning task is given by P, T, and E. Before we start, let's quickly describe what is AI, what is ML, and what is deep learning. AI refers to the algorithms that allow computers to learn without being explicitly programmed. Examples include rule-based systems, expert systems, fuzzy logic, etc. While machine learning is a subset of AI which focuses only on using data to train a machine learning algorithm. This is where the term machine learning came from. Examples include support vector machines, decision trees, and others. Deep learning is also a special subset of machine learning, but instead of having a special algorithm, we are trying only to mimic the human brain behavior in the learning of data. Machine learning. In traditional programming, there is a defined algorithmic steps that the computer executes, which we call a program or an algorithm. And for a given input data, the computer compute the algorithm on the data and produce results. Example could be a calculator, a sorting algorithm, etc. In machine learning, the situation is different. The logic required by the algorithm is not known. However, the output result for a given input is known for several cases, and the output is unknown for some other cases. In this case, the computer produces the required algorithm that maps the input result to the output result using the machine learning concepts. And this is what we call it a training phase. Later in the prediction phase, for any given input, the algorithm computes the expected output. And this is what is called the prediction phase. One may ask, why and when we need to use machine learning algorithms? Machine learning algorithms are more efficient in problems that cannot be easily represented in a mathematical formula due to many factors. For example, unable to identify all affecting parameters, unable to find the best mathematical order to describe the problem. In some other cases, the existence of noisy data can affect the output sensitivity and swing the result from one possible outcome to another. In these cases, machine learning algorithms are likely to produce more robust results. Examples of these problems include pattern recognition, where varying lighting condition or camera position could affect the outcome. This includes face recognition, emotion recognition, speech recognition, text recognition. There is also generating pattern problems, which require some artistic touch and cannot be modeled easily or mathematically. There is also recognizing anomaly, while anomalies are often hidden in a clever way inside regular cases and very difficult to detect. There is also prediction tasks, where future prices of housing or stocks or food need to be estimated and predicted based on many component and factors. Let's discuss some of the problems in machine learning. The first one is the regression problem. Regression problem is problems where there is a set of known input and output data that should be used to formulate the relation between both the input and the output. During the training phase, those known data are used to estimate the relation. Later, when a new input is applied, the training algorithm can be used to predict the expected output. There could be many ways to represent the input-output relation. We can have a linear relation, we can have non-linear relation, we can have higher order non-linear relation. All of them can be used to do a proper estimate of the output for any given input. There is also classification problems, where the objective of the classification problem is to formulate the method that distinguish between two different types of input or more. And this basically classification is based on identifying some features that is uncommon between both classes. Classification problems can be categorized based on number of outputs. So we can have a binary classifier or multi-class classifier. Classification also can be categorized with respect to the separator order. We can have a linear separator between classes, a non-linear separator between classes. Clustering problems are unsupervised learning problems. They are used to identify data points that belong to the same category. Examples include k-mean clustering, which divide the input data into k categories, where k is a user-defined number. There is also DB-scan clustering, which groups things that is within a certain proximity to each other. There are many applications of clustering, such as traffic analysis, social network grouping, urban planning, etc. When comparing machine learning to deep learning, there is only simple difference. In machine learning, the used feature could be handcrafted, hand-created, or designed by a programmer or a designer, while in deep learning, those features are automatically selected by the deep neural network system. The emerging deep learning revolution came due to many reasons. Increased GPU processing power, which reduced training time from weeks to hours. Availability of large or huge labeled datasets that can be used for training. Improved training algorithms that overcome the problem encountered in deep learning training. We're going to cover those later through this course. The appearance of many improved DNN architectures that can be used, they are open sourced and they can be used in solving many existing problems, which accelerate application development. And finally, emergence of fast training platform and tools such as TensorFlow, PyTorch, Caffe, etc. Those tools help developers and researchers to build new models easily and quickly. Someone would ask, what is unique about deep learning? Deep learning provides a flexible learning framework for representing visual text linguistic information. Deep learning can work in supervised and unsupervised manners. It's an end-to-end solution. Deep learning recently has outperformed other machine learning algorithms and techniques. Deep learning is currently spread into many areas in agriculture, health, autonomous vehicles, and so on, due to their recent advance. You cannot use deep learning without knowing one or two deep learning frameworks. Those frameworks are key ingredient for building a deep learning model. They have a lot of tools and libraries that can be used to train and deploy the deep learning models. Most of them are Python based and they are GPU optimized, and they provide different level of complexity for beginners and up to professionals. There are also a lot of tutorials and open source code using those platforms. In this section, I'm going to talk about some of the deep learning applications. Most of the slides are taken from the link below, but there are other slides that you can browse. There are currently many applications in deep learning for different areas, and many more applications are currently emerging in other areas that was not considered before in deep learning. In the following few slides, I'm going to talk about some of these applications. One of the most important applications that emerged in the last few years is NLP applications. The NLP objective is to enhance interaction between computers and the human using a natural language. Computers with NLP capabilities should be able to read, understand, and make sense of human language in a valuable manner. There are several NLP deep learning building blocks, and that includes reading data, performing speech recognition, speech-to-text translation, then text understanding, and finally text generation. And based on this, there is also a large set of applications. ChatGPT is one of them, of course, but beneath ChatGPT, there are other sub-applications that can be used for classification of language, of topic, of sentiment. There is also fact extraction. There is automatic language translation. There is computerized dialogue systems. There's question and answering applications, and there is written and spoken search engines. All of these are part of NLP building blocks. This is one example where there is a text generation and a smart reply in mobile phones. Software generation, where developer can sketch code and the tool can automatically convert it to a code in a few seconds, is also available. You can write an HTML code in few seconds. With respect to image and video, there is object detection, classification, and localization, which is one of the most common and widely used deep learning applications. This can be done for single object or multiple objects. Image colorization is another case where grayscale images are colored using a deep learning model. There is also recognizing activity from a video sequence. Semantic segmentation, where the classification of each class is done at the pixel level. There is autonomous vehicle systems, which rely heavily in deep learning for many use cases, such as object detection, object classification, object avoidance, route planning, automatic braking, and many other use cases. Deep learning are also used in flying drones in many use cases where human or trucks cannot go to. Games are one of the most of deep learning, where deep learning engines are part of the computer. Speech recognition is similar to image recognition, where sentence could be understood and converted correctly to text. Lip reading is very important for several TV applications. Deep learning is currently used to generate very realistic images that are very difficult to distinguish from real images. If you go to this website, you can browse for many images. All these images are for persons that does not exist in real life. There is also multi-domain image-to-image translation applications where deep learning is used to add some kind of extra feature to an image or produce the image with different outlook. Image caption, where you can read, parse an image and describe it in a very high quality descriptive text. And currently, video scene description is another emerging field for deep learning. In summary, in this presentation, we provide an introduction to machine learning, application of machine learning, when can machine learning be used. In the next video, we're going to talk about the basic theory of deep learning. Thank you very much.